So here we'll calculate the work done by a force along two different curves. So the force we'll be looking at is F equals negative yi plus xj minus zk. So before I graph this, let's think about what this will look like. So this we recognize as the angular vector field. So in the xy plane, we're going to be getting this rotational motion and then putting negative zk. So if this is the xy plane, negative zk says the z component is going to be like pointing down or above or pointing, so the z component of our tangent vector is going to be pointing towards the origin. Okay, so here is that vector field, and indeed that looks like what I described. Okay, so now the curves that we'll be interested in. We'll be looking at the work done by F along. So first we'll take the straight line segments going from the origin to 1, 1, 0, and then from there to the point 1, 1, 1. So let's do that. Just do that one first. So our parameterization of that is C1 is R of t is t 0 for t between 0 and 1, and C2 is parameterized by R of t is 1, 1, t, again, t between 0 and 1. Now, the work, so this will be the integral over c of f dot dr. So that's integral c1 f dot. So first we'll break it up into these two parameterizations. Then this is integral 0 to 1. So then f, so here negative ti plus xj, and then just that, because so what we're doing here is we're taking f. So f is negative yi plus xj minus z k dot, and then dr here is I plus j, and then dt. Now along here, y is, this will be, z is 0, so we get rid of that. And so what we have is negative ti plus tj. So yeah, let me just evaluate maybe these individually, or just running out of space. So then the other one will be integral 0 to 1. Now x is, so y, and so this will be negative I plus j, since now these are both 1, minus tk, and then r prime here is just k, so that dt. So this becomes integral 0, 1. So the first dot product is negative t plus t, so those cancel out. And then the second one is minus t, and then dt. So that's negative 1/2. I'll put W1 for the first case. And so then the second curve we'll look at is this more polynomial curve. So maybe I'll write the red work is negative 1/2. And now the blue curve is where c is t squared t cubed for 0 less than t less than equal to 1. So notice these are both curves go from the origin to 1, 1, 1. Okay, so now we'll have f is negative t squared I plus tj minus t cubed k, and dr is I plus 2tj plus 3t squared k dt. So integral 0, 1 f dot dr is integral 0, 1 negative t squared plus 2t squared minus 3t to the 5 dt. So the work for this one will be, okay, so this, so now this will integrate to 1/3, and this will integrate to 1/2. So we get 1/3 minus 1/2 is negative 1/6. So we can get different values for the work depending on which path we take between the 2 points.